This is a simulation of the ballistics cart experiment where a rolling cart launches a ball upward. And it's fun to do this in real life, but there are some advantages of the simulation as well. For one thing, it just about always works, and that you do catch the ball. The other thing is you can run it one frame at a time and talk through what's happening. The ball and the cart have the same horizontal velocity. Now we give the ball a vertical velocity, and so it follows the projectile path, but notice that it always stays lined up with the cart. And of course, now I'll just let it run at regular speed, and we get a catch. But there are some other things we can do here. First of all, you might be wondering what these posts are, these light bulb-like things. I meant them to be like street signs, because what I want to do is take another look at this exact same experiment from a different point of view. So let's look at it from the driver's point of view. From the driver's point of view, the driver's not moving. The street signs are moving. And notice from the driver's point of view, the ball just goes straight up and straight down. Let's look at that again, one frame at a time. From the driver's point of view, it's the street lights that are in motion. And in the driver's reference frame, the ball just goes straight up and straight down. Now, a fun thing to do is to look at what would happen if after the ball was launched, the driver steps on the brakes. So let's watch that again. If you step on the brakes, from your point of view, the ball was thrown forward by the force that acts on things when you step on the brakes, that forward force that appears when you step on the brakes. Of course, we could look at this again from the outsider's point of view, and then we'll be describing what happened differently. Again, we're going to look at the same events, though. So the cart is rolling along, the ball gets launched, the driver steps on the brakes, and the ball lands on the ground in front of the car. Let's look at it again in slow motion. Cart and ball are moving together. We don't think the ball is going straight up and straight down. We think the ball is following a parabolic path like any other projectile. And we don't see the ball being thrown forward. We see the car slowing down. So who's right? Was there a force that threw the ball forward? Or is it just that the car slowed down? Well, you can argue about this, but I feel both observers are correct in their own reference frame.